Hello, my dear students. This is again Teacher Jenny guiding you on the fifth module for quarter 3 of Mathematics 8 with the title Solving Corresponding Parts of Congruent Triangles, taken from the module developed by Femi Dinamling and Jocelyn Gamad. At the end of this video, you are expected to solve corresponding parts of congruent triangles. But before we proceed to the lesson, let us recall first naming the corresponding parts of two congruent triangles given the figure with marked corresponding congruent parts and the name of the congruent triangles. Take note, given two congruent triangles, there are 6 pairs of corresponding parts, 3 corresponding angles, and 3 corresponding sides. Let's start with the corresponding angles. On one triangle, we have angle J, and that corresponds to angle Q. Angle N corresponds to angle T. Angle E corresponds to angle U. Those are the 3 corresponding angles. Now for the corresponding sides, we have first, segment JN corresponds to segment QT. Segment EN corresponds to segment UT. Segment JE corresponds to segment QU. So if you can still remember, in identifying the different corresponding parts, you can either use the arrangement of the vertices on the given name of the two congruent triangles, or you can use the tick marks on the figures of the two triangles. Now, based on this example, it is very evident that when two triangles are congruent, their corresponding parts are also congruent. And that is based on the CPCTC, or the corresponding parts of congruent triangles are congruent. And that two triangles are congruent if their vertices can be paired so that corresponding sides are congruent and corresponding angles are congruent. So given two congruent triangles, we can solve for the measurement of its unknown parts. And that is our lesson in this video. How are we going to solve for the corresponding parts of congruent triangles? But before that, always remember that solving involves finding for the value of the variable. So before we proceed, let us recall first how to solve for equations in one variable. So say for example, we have 2x plus 5 equals 13. Now to solve for x, we have to isolate the variable x on one side of the equation. And to do that, since we have two terms on the left side of the equation, we have to get rid first of the term without the x variable, and that is plus 5. Wherein we can apply the addition property of equality, or we can transpose positive 5 to the right side of the equation. So if we transpose positive 5, we only have now 2x on the left side. And then, to transpose positive 5, the sign will change. So from positive 5, it now becomes negative 5. Simplifying the right side of the equation, we have 13 minus 5, that's 8. So we now have 2x equals 8. And to solve for x here, we have to apply the multiplication property of equality, which is done by multiplying 1/2 to both sides of the equation. That is to get rid of the numerical coefficient of x, which is 2. Or we can just divide both sides of the equation by 2. So 2x divided by 2, that's x, and 8 divided by 2 is 4. So we have x equals 4. So with that, I know that you are already ready to solve the corresponding parts of congruent triangles. Let us have examples. First, given triangle TWO congruent to triangle ISX, the measure of angle O is equal to 55 degrees and segment SX is equal to 4 units. Let us find first the measure of angle X. Now, to solve for the measure of angle X, we have to identify first its corresponding congruent angle on the other triangle. From the name of those two congruent triangles, it's very evident. Now, on the given name of those two congruent triangles, it is very evident that the angle that corresponds to angle X is angle O. So on the figure, this angle corresponds to this angle. That means the measurement of angle O is equal to the measurement of angle X. Now, since the measurement of angle O is equal to 55 degrees, then it follows that the measure of angle X is also 55 degrees. Next, we have to find for the measurement of segment WO. But before that, we have to identify first the side that corresponds to side WO. So this is WO. That means it corresponds to side SX or segment SX. On the figure, this side is congruent to this side. Now, since segment SX measures 4 units, it follows that the measurement of segment WO is also 4 units. Next example. Given triangle UBD is congruent to triangle DIR, and segment UD measures 43 units, and segment DR measures 2x plus 3 units. Find the value of x. First, we have to identify the relationship of those two given sides of the two triangles. But since the figure is not given, then that means we're going to base only on the given name of the two congruent triangles. So we have segment UD and segment DR. So obviously, those sides are the two corresponding congruent sides of those two triangles. That means they must have the same measurement. Now, since we are looking for the value of x, we can now equate the measurement of those two sides. So we have dr is equal to ud. Or the measurement of segment DR is equal to the measurement of segment UD or vice versa. By substitution, DR is equal to 2x plus 3 and UD equals 43. Now, to solve for x, we have to get rid first of positive 3. So, transpose positive 3 to the right side of the equation. So, we now have 2x is equal to 43 minus 3. So, from positive 3, we now have negative 3. When you transpose, you must change the sign. Remember, when you transpose, you must change the sign. Simplifying the right side of the equation, we now have 2x is equal to 43 minus 3, that's 40. Since we now have 2x is equal to 40, to solve for x, we divide both sides of the equation by 2. So 2x divided by 2, that's x, and 40 divided by 2, that is 20. Therefore, the value of x on the given problem is 20. So that if we substitute 20 to the measurement of segment DR, we have 2 times 20, that's 40, plus 3 is 43. So it's the same with the measurement of segment UD. Next example. Find the value of x given that triangle ABC is congruent to triangle PQR. Now, since we are asked to solve for the value of x, we have to consider the parts of those two triangles with given measurements. So we have this side with measure 2x plus 6 and this side which is 20 units. That's AB and PQ. On the given pair of congruent triangles, we have AB and PQ. So note that those two segments are congruent. That means the measure of segment AB is equal to the measure of segment PQ. By substitution, we now have 2x plus 6 is equal to 20. Solving for x, we have to transpose positive 6 to the right side. So we now have 2x is equal to 20 minus 6. And 20 minus 6 is 14. So we now have 2x equals 14. Then dividing both sides of the equation by 2, we have x equals 7. Therefore, the value of x on the given problem is 7. Let us check. Using the measurement of segment AB. So that's 2x plus 6. By substitution, we now have 2 times 7 plus 6. 2 times 7 is 14 plus 6, so we have 20. Same measurement with segment PQ. So the answer x equals 7 is correct. Next, we have this example. Find the value of variables x and y in the given figure. Take note, in this problem, the given is the figure with the marked congruent sides. Let's solve for x first. Considering the sides with the variable x, we have this side with measure 7x minus 4. Take note that it has 2 tick marks. That means it is congruent to the side with 2 tick marks also on the other triangle. So that is equal to 31. Equating those measurements, we have 7x minus 4 equals 31. Transpose negative 4 to the right side. So we have 7x is equal to 31 plus 4. And 31 plus 4 gives us 35. Now dividing both sides by 7, which is the numerical coefficient of x, we now have x is equal to 35 divided by 7. So we have 5. Let us check using the measurement of one side of the triangle, that is 7x minus 4. By substitution, we have 7 times 5 minus 4. And 7 times 5 is 35 minus 4, so we have 31. The same with the measurement of its corresponding side on the other triangle. That means x equals 5 is correct. Now we have solving for the value of y. On the first triangle, we have this side with the measure 4y equals 8 with 3 tick marks. On the other triangle, the side with 3 tick marks is the side with measure 24 units. That means we can equate the measurement of those two sides. So we now have 4y plus 8 is equal to 24. So solving for the value of y, we transpose positive 8 to the right side, and that gives us 4y is equal to 24 minus 8. 24 minus 8, that is 16. So we now have 4y equals 16. Now, dividing both sides of the equation by the numerical coefficient of y, which is 4, we now have 4y divided by 4, that's y, and 16 divided by 4, that is 4. That means y is equal to 4. Let us check. From 4y plus 8, we now have 4 times 4 plus 8. 4 times 4 is 16 plus 8, so we have 24, which is the same with the measurement of one side of the second triangle with same number of tick marks. That means the value for y, which is 4, is correct. So again, in this problem, the value of x is 5 and the value of y is 4. Let's now have the next example. Find the degree measure of the angles in the given rectangle. We have this rectangle ABCD. Since there are no tick marks, we have to identify first the corresponding sides based on the definition of a rectangle. Take note that in a rectangle, the two opposite sides are congruent. That means this side is congruent to this side. And this side, side AB, is congruent to side CD. And for the third corresponding side, we have this common side, which is the diagonal of the given rectangle. So we have triangle ABC is congruent to triangle BCD. And then for the angles, we have, of course, angle A is congruent to angle C because all the vertices of a rectangle measures 90 degrees, all right angles. And then this angle, which is the included angle of the two sides with 2 and 3 tick marks, is congruent to this angle, which is the included angle of the two sides with 2 and 3 tick marks on the second triangle. And for the third pair of congruent angles, we have this angle, angle ADB, is congruent to the remaining angle on the second triangle, that is angle BDC. So we have this one. Take note that the only angles with given measurement are these two congruent angles. That means we can equate now the measure of angle ABD and the measure of angle BDC. By substitution, the measure of angle ABD is 11x minus 3 and the measure of angle BDC is 9x plus 9. Solving for the value of x, we should isolate those terms with the variable x on the left side of the equation and the terms without the variable x on the right side of the equation. So when we transpose 9x to the left side of the equation, it becomes negative 9x. And when we transpose negative 3 from the left side of the equation to the right side, it becomes positive 3. Simplifying the equation, we have 11x minus 9x, that's 2x, and 9 plus 3 is 12. So we now have 2x equals 12. So to solve for x, we have to divide both sides of the equation by 2. So that is now x equals 6. So the measure of angle ABD is equal to 11 times 6 minus 3 by substitution. So that is 11 times 6, that is 66, minus 3, so we have 63. So the measure of angle ABD and the measure of angle BDC, since those two angles are congruent, we have both 63 degrees. And then, of course, for the congruent angles, which are right angles, we have 90 degrees each. So for the remaining congruent angles, angle ADB and angle CBD, we can have two solutions. First is by considering that all the angles formed by a rectangle measures 90 degrees. So we have 90 degrees minus 63 degrees, and that gives us 27 degrees. Or you can use the sum of the interior angles of a triangle. That is 180 degrees. So take note that the sum of the interior angles of a triangle is always equal to 180 degrees. So if we do not know the measure of one angle of a triangle, that can easily be done by subtracting 180 degrees to the sum of the measurements of the two given angles. So that's 180 degrees minus 90 degrees plus 63 degrees. So 180 degrees minus 153 degrees, that is 27 degrees. So now we already identified all the degree measure of the angles in the given rectangle. We have 90 degrees, 63 degrees, and 27 degrees. Let's now have the last example. Using the marked parts in the figure below, solve for the unknown corresponding parts. So we have to look for the value of this Greek letter theta and Greek letter phi. Then we have here x and z. First, we can easily determine for the value of theta, that is equal to the measurement of this angle with measure 25 degrees, because take note, they are vertical angles, and vertical angles are congruent. Therefore, if angle ECD measures 25 degrees, it follows that angle BCA, or the value of theta, is equal to 25 degrees. Next, we have the value of Z. Take note that this side is congruent to this side. So if this is 9 units, then the value of Z is also 9 units. And the next, we have this angle. Take note that this angle is congruent to this remaining angle on the second triangle. And to find for the measurement of those two angles, we have to use the fact that the sum of the interior angles of a triangle is equal to 180 degrees. So we have x is equal to 180 degrees minus the sum of the two given angles, that's 90 degrees because this is a right angle, plus 25 degrees. Simplifying, we have 180 degrees minus the sum of 90 and 25, that is 115. And 180 minus 115, that gives us 65 degrees. Therefore, the value of x is 65 degrees, and it follows that the value of the Greek letter phi is also 65 degrees. So that ends now our illustrative examples in solving the corresponding parts of congruent triangles. But before we end this video, remember that in solving corresponding parts of congruent triangles, you have to bear in mind the CPCTC, or corresponding parts of congruent triangles are congruent. So you have to identify first the corresponding parts of the two congruent triangles to compare their measurements. And in solving, you must apply your skill in solving equations in one variable. That ends our video. Thank you for watching.